Hi, we are group 12, and we decided to make a rocket launcher, and we named it Apollo 11 Takeoff. So the agenda, we'll just kind of go through the story behind our toy, some concept generation or final design, and individual pieces that contributed to making ours. We'll show some demonstration videos and things we do to improve it if we had more time. So just kind of going to the background about why we made this toy. This is inspiration for this was basically Apollo 11 mission with Neil Armstrong. Purdue has sent 23 alumni into space. We thought that was pretty awesome. Very well-known university for space exploration, so we thought that was a good justification for why we should make a toy revolving around that. This is a toy that's powered using compressed air, so if we had to give an age range for this toy, we'd probably say 12 and up, just to be safe.
So, the first thing we would like to discuss is the unique selling points about this toy, that why this toy should actually be in the market. We designed the launch mechanism of the rocket like a missile silo, so it kind of makes the toy look cool, because kids at that age kind of want things that look appealing to them and things that they can talk to their friends about. So definitely it should be something that looks cool and they think is cool. And also the mechanical aspects of this toy definitely initiates learning about the toy. That's definitely something as Purdue students we want to initiate at a very young age, so that they learn from a very young age. And we have a variable pressure gauge on this toy, so you can actually control how high you can make the rocket fly, depending on how much you pressurize the tubes, which will basically is in direct correlation with how high it flies. And this is important because this toy can be in different environments. It can be in an open environment where you could fly it as high as you want, but it could also be used in a closed environment in which you would want to restrict how high it flies. So definitely controlling the pressure is an important aspect in this toy. And safety is one more thing that we definitely want to initiate with this toy, since it's going to be primarily used by kids. So we don't want them to hurt themselves or hurt anyone in the process. So we covered the rocket in foam. So even though it flies at a pretty decent velocity out of the launch base, it's covered in foam, so it should not break things in the surrounding or hurt people in the surrounding environment.
So that's basically our concept generation. We pretty much on the spaceship and launcher. That's what we initially want to do, and we want the rocket to lift up vertically, like the animation picture shows. Previously we want like a gear power, like a gear powered fan to power up the rocket, but then now it doesn't give that too much power, so we switched the air pressure. We found the safety issues, and pretty much it's a toy. We want it to be fun and inspiring.
So as you can see in our final design, we have a tube which is connected from the, we can use any device to pressurize the tubes. In this case, we just use a bicycle pump. So the tube connects to a valve. So this valve holds the pressure initially. So once you reach the desirable pressure, you just open the valve, which will launch the rocket. And then after that is a launch base. So the launch base contains a variety of things. It has an iris mechanism and a gate. This gate and the base was originally designed to lift vertically, but due to some problems we had after 3D printing the parts, we had to glue it down. And as we mentioned, the rocket is powered by air pressure. And last but not the least, it causes vertical liftoff. And this is kind of a video of what our project looks like.
So as you can see, the spaceship's rising as the iris mechanism's opening at the top.
So the key features in this are, as I mentioned, the base housing, the iris mechanism, and the rocket assembly, which we will talk in detail from here on.
So I spent my part on the base housing, and We actually wanted like the platform to be reasoned up, but since we have some material issues that tilt out our platform, so we have to abandon that feature to lift off in our demonstration. But basically, the outer shell is just designed as a nuclear silo, and it was able to hold out the array system, which Glenn is going to talk about.
Yeah, so the next key feature that we had in our design was the iris mechanism on top. This is just a gate on top of the housing to allow for the rocket to leave the base. So it is a circular enclosure which opens up from basically a rotation of this top pentagonal piece. A rotation, basically, as you can see from the motion skeleton, there are basically two basic components with the iris blades and then the linkages. You slide this linkage along its track, and then it will rotate the whole piece and open up the blades. So there will be 5 of them creating a circular enclosure. And this is a model of what we have for our Creo mechanism and how it works with opening the top and then the blades sliding open.
So the next is the rocket assembly itself. It's covered in foam, so we are unable to see what's inside. But essentially, the idea is the tube is connected to, this tube is connected to a 3D printed tube, which has a helical sweep around it, and then the main body of the rocket, which is covered by the foam, has like a small helical sweep on it, so that it sits on the helical sweep of the inner tube. So the reason we made this helical sweep is so that when the rocket actually lifts off, it follows the helical sweep and spins while taking off. And the idea was inspired from a bullet, so that the rocket actually flies in a straight path, because when it's spinning on its axis, it will actually take a straight path rather than going in a wayward direction.
So here's a side-by-side view of our Creo model and our finished prototype. They're very similar in terms of how they look, I guess. And so here are 2 videos of our demonstrations. The video on the left is opening the iris. At this point, the platform is supposed to rise with it, but we had problems attaching the hose. We weren't really considering in the design how it would affect the platform itself. The platform was supposed to rise from a pulley system, but the hose was a little bit more sturdy than we expected, so it kind of lost the tension in the strings from that. And then here's a video of our initial launch. It's not very exciting in this video. It just barely pops over the gate there. So
We were happy we got it to move.
yes, that was our original, and then yeah. So
So for
yeah.
some of the design improvements, we'd like to make the iris like fully enclosed. As you can see, it's very open. That was due to the volume constraints that we had to work with. In addition to that, we painted it, and there was a lot of stickiness associated with the paint, so it caused our parts to move a lot less than what we wanted them to. So for that, we obviously improved that, get better tolerances. For the housing, we'd like to make it fully enclosed and actually have the platform rise as we anticipated. And for the rocket, less rotation on it, so there's less friction as it's going up, because that severely slowed it down in the beginning. And then we actually did switch it to a ball valve last night at the last minute after that video was taken, so it goes a lot higher now. So we were initially using a gate valve, which, I don't know, the air just wasn't going in as quickly as we needed it to, so we switched to a ball valve late last night. And then from there, we'd like to add sound effects, like as the rocket rised up, to make it kind of cool for children who are using this. Remote control would be also a lot safer, I don't know, kind of operate this from a distance, and then just like a better carb rocket in general. Thank you. We're going to do like a short demo just to show how that works. Yeah.
So if you can see it, we're about to launch it. Gonna work. So the major difference from the video that you saw earlier in the actual demonstration with the valve The gate valve we originally had didn't open quick enough, so the ball valve has just a quarter turn from open to close, whereas the gate valve was 4 rotations to open up the gate, so it allowed the air to pass through a lot quicker. So are there any questions?
We wanted to rifle out, just to make sure it stays straight and not immediately go a different direction upon exiting. Oh, so there's only one thread.
Like the pitch?
Oh, so we wanted to ideally not have too much around, like, yeah.
And one more thing we had to take into consideration while designing the pitch was the angle of the pitches. Because if the angle was too horizontal, it would cause too much of a reaction force, which would lose a lot of energy at the launch. So it had to be an optimal design between the number of helixes and the angle of the helix, so that there's not much friction and reaction, which will cause the rocket to lose its height very initially. And the main idea of the helix is from a bullet in a gun. Like, the bullets of a gun have those oblique curves, and those are to ensure that it's spinning on its axis and it goes in a straight path. So that's the same inspiration that we use for our rocket design.
What's your original idea about connecting this opening of this valve with the opening of that gate, Alice gate? So should be once you open this valve, this gate should open. Right? So right now it's manually. So what's your original?
Actually, we should manually open the gate. There's a pulley system that connects, like when we rotate it, it's connected to the bottom platform. There's a platform that should raise up. So as we turn it, the pulley is gonna pull the platform up. That's our original idea. But the platform was not stable enough to hold the rocket by its launch. So
I mean, we were never planned to connect the valve to the mechanism. It was always intended to like rotate the gate manually. So it's like first you open up the gate and rise the platform, and then you power the rocket. It was never intended that the valve is somehow connected to the mechanism of the design.
Okay.